Pyramids differ from prisms because instead of having two parallel bases that are the same shape, like triangles or rectangles or trapezoids, we have a base, and the opposite of that is just a point. So we have two types of pyramids that we use commonly, and that's the square pyramid and the triangular pyramid. The square pyramid has a square base with a point on the opposite, and triangular has a triangle base and the point opposite. What you can kind of think of this as is a cube, or some kind of rectangular pyramid. And imagine collapsing this top part. Imagine shrinking it all down to a point. It goes to this point here. That's what you kind of get. We have on the bottom here, we have a square base, and that goes up to the point. So there are going to be 5 sides to this triangle: the square base and 4 triangular sides on top. The triangular pyramid is the exact same idea. Imagine taking this top portion and shrinking it down to a point. So it goes to this thing here. In this case, we have just one line that goes straight across. And so there's going to be 4 sides to a triangular pyramid. The triangular pyramid has 4 triangular sides. The square pyramid has 4 triangular sides and a square face. So to find the surface area, it's the same idea for prisms. Calculate the surface area using what you know about the shapes of the different sides. For the square, we're going to have a square side, or a rectangular side, I should say. Rectangular side, this is going to be base times height, or length times width, whichever one makes sense. The triangular sides are going to be 1/2 base times height. For the triangular pyramid, all of the sides are going to be 1/2 base times height. Now, what's important here to note is that the height of the pyramid is not the same thing as the height of the sides of the triangles. In fact, there's a different phrase used for that, and it's called the slant height. The slant height, I'll do it in blue here, is the height of the side. It makes a right angle with the side. So the slant height, as long as it's the exact same, it's a square triangle with the exact same dimensions on each side, the height's going to be the same. But that's what the slant height is. It differs from the height of a pyramid. The height of a pyramid, in red here, get rid of this blue, is the distance from the very top of it down, straight down to the base. It makes a right angle. It's what's called orthogonal, meaning it makes a right angle in every direction. And it's the exact distance between the point and the base, be it a square pyramid or a triangular pyramid, whichever one you're talking about. The triangular pyramid is going to look like this. Makes a right angle with the base there. Okay, so keep that in mind when you're looking at the figures on your homework and tests and things like that. The height of, or also called the altitude, so height of the pyramid equals the altitude. That's kind of a better way of describing it. And the slant height, I'll do it in blue here. Slant height, that's the height of the 2-dimensional side. Okay, to find the volume of the pyramid, so the slant height is going to be used in the side measurements. And the volume, to find the volume of this thing, we're going to take 1/3 times the base area, so be it a square or a triangular base, the base area, and we're going to multiply it by the altitude, or the height of the entire thing. You can use either, I'll put A here, no, that sounds like area. I'll put, let's put H as the height or the altitude rather than the slant height. Make sure you understand the difference between those two things. Okay, let's look at this thing in practice. All right, I have a square pyramid here. This is a square pyramid, and this one is triangular. That's because this bottom part here is a square, and this bottom part here is a triangle. I should say in the bottom. Okay, now we can use what we've just learned to find the different pieces of information. So for the surface area on the square pyramid, we have a square on the bottom. Well, the area of the square is going to equal length times width, which is 2.5 times 2.5. And that gives us 6.25. And this is going to be in inches squared. It's an area, so it's going to be squared units. Okay, that's the bottom surface area. Now we need to find the 4 triangular sides. We have triangle 1, triangle 2, triangle 3 is on this side, and triangle 4 is on the back side. The triangle 1 has a, to find this is 1/2 base times height. The base of this triangle is the bottom part is 2.5. And the height of this is the same thing as the slant height. That's the distance. Let me move T1 here. That's the distance from the bottom part of this triangle all the way up to the point. That makes a right angle. So that's the height we're going to use for our area calculations for the side faces. Okay. 0.5 times 2.5 times 6.13. That gives us 7.6625. This is inches squared. And you'll notice that this is the exact same thing for each of the sides. T2 has a base of 2.5, and the slant height is given as one thing, so you can assume that all the sides have the same slant height. Which means all we have to do to find the surface area of this whole pyramid, this whole square pyramid, is to add up the base, the bottom square, yep, and 4 of these triangular side areas, which each one is going to be 7.6625. So doing that gives me 7.6625. I get 36.9, and that is inches squared. So that's the surface area of this square pyramid. Now to find the volume of it, the volume of the square pyramid is going to be 1/3 times the area of the base. The area of the base is this bottom part here. It's opposite. It's going to be always opposite the point. So this is the point right here, and going straight down from that point gets us to the square. And this distance here is the altitude. So the base area is going to be 6.25. That's the area of the square. That's what we just found here. And the altitude is going to be 6 inches. So doing that, 1/3 times 6.25 times 6 gives us 12.5. And this is going to be in cubed units, so it's going to be inches cubed. And that's the surface area and volume of the square pyramid. All right, now for the triangular pyramid. Similar kind of steps that we're going to do. Let's find the base of this triangle. What you'll notice is that each of these side bases are 13. And that means the base is actually going to be an equilateral triangle. But we're going to use these measurements, however, to find the certain pieces. So let me take this bottom triangle and draw it a little differently here. You can look at it like this as it's drawn there, but I'm going to actually flip it around. And it's going to be the same thing. All of the side lengths are 13. Now we're trying to find the area of this triangle. We need to know what the area is to find the rest of it. To do that, we do not know what the height of this triangle is. To find the area is 1/2 base times height. The height is going to be this distance here. We don't know what that is. We can, however, find that distance. We can use Pythagorean Theorem to find the distance there. That's because this height is going to cut this bottom part in half directly. And 13 divided by 2 is 6.5. So each of these measurements here are 6.5, this one and this one. Now to find the height, we're looking really where we can ignore this side here. Just ignore it for a moment. And you notice that this right here is a right triangle. And we can find the third side of a right triangle if we know two sides by using the Pythagorean theorem. So by the Pythagorean theorem, right, the opposite side of the 90-degree angle is the hypotenuse. So a squared plus b squared equals c squared, right? The two side lengths are going to be a and b. It doesn't matter which one you name which. And the side opposite the 90-degree angle is always c. That one does matter. The hypotenuse is always c. Okay, we have 6.5 squared plus b squared equals 13 squared. 6.5 squared is 42.25. 13 squared is 169. Now to solve for b, we need to subtract 42.25 to the other side. Giving us 126.75. And to get rid of this square unit, we have to take the square root. That's always how you get rid of the square. And I've talked about this before in different videos, but if you take a square root, you have to worry about the plus or minus version. The same reason why x squared equals 4, that's both 2 and negative 2. But whenever you're talking about distances, like we are here, it's always going to be positive. So it's going to be the positive of the square root of 126.75, which gives us approximately 11.26. That's what this side here is going to be. I can delete a lot of this stuff. This central height here is 11.26. Now, we can find the area of the base. So the area of the base is 1/2 the base, which is going to be 13. One of the side lengths, doesn't matter which one because they're all the same, times the height, which is 11.26. You should really always use the side length that's the right angle. Let me show it right here. The right angle of the height, because that's formally what the base is known as. Okay. 0.5 times 13 times 11.26 is 73.19. Now, that was the area of the base. That was a little more difficult because we had to find the height. It wasn't given to us. However, the last three sides here, triangle 1, triangle 2, and the back side here is triangle 3. The last three sides here are all the same, and the height is given to us as the slant height here. And the bases of all these triangles are going to be 13 centimeters because that's all of those bottom measurements are 13. So we can find the area of those things, 1, 2, and 3, is 1/2 times the base, which is 13, times the slant height, which is 16.4. Doing that gives us 106.6. All right, and now to find the surface area, we just add up all four sides together. 73.19 plus 3 times 106.6. That's because there's three sides of the triangle. Each side has 106.6 for the surface area. Okay, do it in the calculator. Times 106.6 gives us 392.99, pretty much 393. This is going to be in centimeters squared. So it's a long process because we had to do a separate thing to find the base of this triangle. You can always do this process as long as you know two of the sides. You can always do this process. If it's an equilateral triangle like this one, then it makes sense that it would cut it in half into 6.5 and 6.5. And then you can just look at this right triangle here and use Pythagorean theorem. It's a very common thing, a common type of problem. It uses the spatial reasoning and Pythagorean theorem to prove something. And it's kind of a nice use of all the different things you've learned about in this class. Okay, so that's the first part. The next part is the volume, and that one's actually going to be a lot easier. Let me remove some of this stuff. The volume is just 1/3 times the base area, which we already found as the same thing as this. This is the base area here. The volume is 1/3 times the base area, 73.19, times the height, the distance between the base and the point of the pyramid. And the pyramid's height is the same thing as the altitude, which is 16 centimeters. So we have 1/3 times 73.19 times 16. That gives us 390 point approximately 0.35. This is a volume, so it's going to be in centimeters cubed.